So what we're going to do is cut 2 pieces of aluminum foil, and we want to make them either smaller or about the same size as this piece of plexiglass. So what I did is I put the piece of plexiglass on top of the aluminum foil, then I cut the pieces off. Now what I've done is I did it a little bit ahead of time, and let me show you what they look like. They're pretty much exactly equal to the plexiglass, except for a little tab at the top. Now the tab is so that I can measure this. It's like to grab. I use little alligator clips to grab onto that tip. So I've got 2 of these sheets. So what I'm going to do is put them on this cork board, which is a nice insulator. I'm going to put one down. Let's see, I put them down in this direction. Okay, so there's my first one. Then I'm going to put the plexiglass, which is the insulator, on top of this. Okay, I can see that I'm a little bit too... Let me see. I may not have made these things exactly. I want them to be exactly the same size. Let me just see here. I'm just going to put them together. I may have to do a slight bit of trimming here. Okay, they look almost... Yeah, okay, they look the same. Okay, they're hanging over a little bit on that one end. It's probably because they had the plexiglass the wrong direction. There we go. So, there we go. So I've got the aluminum foil, then I've got the plexiglass, and you can see the little hook. I'm going to put the other one on top of it, but I'm going to flip it so that the hook isn't on the same side. Remember, we don't want any sort of shorting out of the electrical circuits. And so I've made a capacitor. Now all I'm going to do is measure it using my meter. Now, first we want to do before we do that is we're going to measure the area of the plate, which is basically the plexiglass. So let's go ahead and measure the length and the width of the plexiglass. All right, so let's put 0 at one end and the other end. Oops, I want that perpendicular. Looks like it is, wow, it's dead on 14. So that is 14 centimeters. 14 centimeters, and it's slightly, it's not exactly a square. Oops. I'm just trying to use the inches. This side is a little bit less than 14, so I put the 0 right there. 13.3. 13.3. Okay, 14 and 13.3. Now that we did that, I'm going to sandwich them together again. Make sure they're not touching. Okay, at this point, what I'm going to do, before I do that, I forgot, I have to measure the thickness of this. The thickness. Because remember, in the capacitor equation, in the theory section, remember the equation, you have to know both the area of the plates and the distance between the plates. So go look that equation up. It's A over D. It's kappa epsilon 0 A over D. So the area, the capacitance equal the area of the plates divided by the distance between them separated, which I'm going to measure right now. Then you have to multiply by the dielectric constant times the permittivity of free space. So epsilon 0 is the permittivity in a vacuum. You can think of the permittivity of free space as how our universe reacts to electric field, electric charges. It's how strongly the universe is, or the space in our universe is affected by a charge. So if that constant was higher, then a charge would have a greater effect. It's the same thing as the gravitational constant. It tells how gravity, the gravitational force, is apparent in our universe. If that gravitational constant G was much larger, then much smaller masses, we'd see gravitational effects with them. But the gravitational constant is very, very, very tiny. So unless you have enormous masses, you're going to have virtually, that's why we don't talk about gravity in chemical reactions that much, because gravitational constant is so small. However, the electrical constant is quite large. So very small charges are going to have an effect and the space around them. So let's actually measure D. I keep talking a lot, but it's like I'm talking about electrical. So I'm going to take my vernier calipers and I'm going to, yeah, that's about right. So now let's read off our vernier caliper. Now remember how we did this? Okay, let's try. This is better. All right, we can see them much better now. Okay, so the first thing you want to do, let me find something to point with, is you look at the 0 here, and the lower band is in centimeters. So this is 0 centimeters, 0.5 centimeters, 1 centimeter, 2 centimeters. What you want to do is look at the very first tick and move upward. Notice how it's right around 3 millimeters. It's less than 1 centimeter, so it's a millimeter. So it's 0.3 and then something centimeters. So it's 0.3, and then what you do is you count the number of ticks to where it's lined up again. Now notice it's the last one, so it's exactly at 0.3. So the thickness of my dielectric is 0.300 centimeters. 0.30 centimeters. I put an extra precision there. So what would be that in meters? 0.00030 meters. And then the precision is 0.0001, plus or minus 0.0001 meters. Got that? It's 3 millimeters. So now you can calculate your capacitance, and let's just quickly measure it. I'm just going to set up my system now. Show you what I'm doing here. And then turn on my meter, hook it up, and then we will have our first exercise. So I am putting, I'm just plugging in my little patch cords into the meter. And let me turn it on. You can't see the meter. Power, there it goes. Let me move it up here so we can put it. So it's moving around. It's on auto range, which is what we want. We want to, okay, that's good. It's moving around a little bit right now. And again, what happens is because of the capacitance of my connectors, if I take these connectors off, you can see it reads 0. Again, number one rule of measuring anything in a meter, the wires that you use to measure them have resistance, and they also have capacitance. When we plug these two black and red things in, they're very close to one another, so they're acting, and air is in between them. That can have small amounts of capacitance in there, and that's what we're measuring. So again, watch what happens when I actually plug the wires in. I'm not even plugging to any sort of capacitance whatsoever, and you can see that it's reading a very small amount. And that's like 2 picofarads, which is enormously small. So it's basically, and if I move the wires around, you can see they change a little. I've just touched them together. So now what I'm going to do is go ahead and hook one of these things to one end of the tab. So here we go. Put that one there. And now at this point, I'm going to have to hold it down, and I'm going to put a book on top. Oop. Don't rip off. Where did my book go? Oh, there it is. Great. This is the problem with only having 2 hands. What I'm actually going to do is put the book down first, and then put the clips on, so that. But I have to be very careful to line up the plates. If I have any sort of misalignment, I'm going to be a little off. And the reason why I use the book is because of the air spaces. The capacitance, of course, is inversely proportional to the distance. So if the distance is smaller, the capacitance gets larger. Okay, so I'm not reading anything. Okay, so there must be a short. Oh, there. Wait a minute. There it goes. There's a short somewhere. I think perhaps one of the sides is touching. I will be right back until it may take me a while to fix it where it's shorting out.